Hello and welcome back. Today it's a lazy Sunday, and I was just looking at all the dummy loads I had, and one is bigger than the other, and they have all different, of course, power ratings, but also different frequency ranges, and that made me think a little bit because if you build one yourself, well, this I built like I don't know 30 years ago, or even before that. And different frequency ranges. So you can not just use any dummy load for any frequency, and the frequency is very, very important because we are not talking here about pure resistance. We are talking about impedance, and the impedance will change on a certain frequency, and that also is the quality of the dummy load or the way it's constructed. Sometimes it's made only for low frequencies and sometimes it's made for high frequencies. So I got a few different ones. You also need different SWR meters. So here are my SWR meters. I have one here for I was very, very happy to find this one. I started with these two. My dad gave these to me. He was not using them anymore, and because I wanted to be in the same range from Daiwa, I actually bought this one second hand, because this one is the lower frequency. This is up to 30 megahertz, even 1.8 to 150. Then this one goes from 140 to 450, and then there is no ham band in between, but then there is 1.2 up to 2.5 gigahertz. So now I have the whole range in the same series. Pretty cool. But because of the frequencies are so different, you also need different SWR meters. If you have a WR meter that goes from 1.8 all the way up to 2 gigahertz, you probably have band switches or different RF pickup that needs to probe the RF. And then they put, of course, some diodes to get the forward and the reflected. And well, the energy is just via induction. It goes to the meter, and then with some resistance you have your power. But that pickup of that RF probe is of course different also on different frequencies. So to see the difference in those RF probes or RF pickups, I just forgot the name, what it is called, but it's kind of a probe. It is usually a wire in parallel, and the better the meter, the better they have housing around it, and so you don't get radiation. And so we can see the difference between these three meters, but let's go back to the dummy loads. Well, and you can probably guess, the worse it is constructed, the less high the frequency it can do, or it was just not designed for this higher frequency. And the lower the frequency, the closer the impedance is to the resistance itself. And here I have more or less 50 ohms. We can measure that, but the way it is constructed, I didn't have a clue. It will probably not go very high, so it would be interesting to see at what frequency the SWR really starts to be terrible, and why the SWR will be terrible, because the impedance is changing. So then I have here a few very professional dummy loads. I get back to those later. Will be great. We'll get to that later. This one also. First, I had a video about this one. This is from the 60s somewhere, made in the USA by the Philco company. It's the Sierra. It's I think it was a part of the Ford Motor Company even. And this one is constructed for 2 megahertz up to 30 megahertz, and it can go up to 500 watts, and that are not MFJ 500 watts. Now these are real continuous watts. And well, I would even think it can do a kilowatt. It probably can, but not continuously. Then I have here a ham, and this one is from Kenwood, and it can do 300 watts up to 60 megahertz. And up to 150 megahertz, you see already here, it starts to go from 1.1 to 1.4. So, and it is here 300 watts. and I know it can do a kilowatt for 1 minute. I saw in the specifications. So here they are pretty honest about what it will do. So the thing is, these huge, impressive looking dummy loads are not useful for 70 centimeters. This one only for HF. This one you can do a little bit of 2 meters up to 150 megahertz, but it is already 1 to 1.4. And yeah, what about 70 centimeters to 430 megahertz, or 23 centimeters above 1200 megahertz? I can't use this dummy load, or can I? We're gonna play with that. But a few months ago, John sent me a very, very nice present. Oh, here it is. This present was from John from the USA, the W7 Zulu Quebec, and I'm really, really thankful for this, because this is one of the most professional things you can find, I think. This, for instance, is it's a bird dummy load / attenuator, and this one is made by Bird for the Harris transmitters, and these have many kilowatts. And to monitor all these transmitters, they have these attenuators. So here is the input and connector, and here it goes out. I think this is 40 dB less on the output, so that makes it more, yeah, it's better to handle, because what can you do with the kilowatt on your spectrum analyzer? These ones go up to 1.2, maybe even double. And here is another one. I think this is also from Bird, 500 watts. And I think I found some specifications out about this one. This one I could not find too much. So this one, 500 watts, also up to a few gigahertz. There is an input there. And this one has an attenuation of 30 dB. And it's also N out here. And the big one here in the back is oil filled. The Kenwood on top here is also oil filled. You can hear. This one also. This is not. This one is not. I think it is constructed with like these resistors, but then a lot better quality, because this one says 250 watts, but of course without the heating element it is not even a few seconds 250 watts. And yeah, you just need to do it a lot better. And as you can see in this one is meant to put on a heatsink, and it has a huge contact to transfer all the heat. You can screw it with 10 so it needs to be really, really stuck to be able to dissipate, that it can actually do 1000 watts as it says here, because like this it will not able to dissipate all that heat. And here it seems even they did even a better job. So this one probably can go up to higher frequencies, because the way it is constructed, the heatsink is almost in one. It is almost in one piece. So the more professional you wire it, the better you connect everything, the higher quality the components you use. It will be for a higher frequency. But we can put that to the test. I cannot do a kilowatt. I can do, depending on the frequency, I can go up to 100 watts. But I'm pretty sure none of my dummy loads will be very impressed except for my homemade. Well, what I actually wanted to do on my lazy Sunday was actually just adjust a little bit my SWR meters. Now I have the series complete, and I wanted to clean them a little bit. And some are even missing feet. I want to fix that. And well, it's just, well, they are probably also 25 years old or a little bit more. And I wanted to see if I still need to adjust them, because the RF pickup could have changed a little bit. and yeah, just see if it works. But then I was looking at the frequencies and my dummy loads, and then I think, oh, I need different dummy loads. And then I remembered, oh, John sent me for the high frequencies, and I found that one also. So I said, okay, now I'm gonna make a video about this, because you don't necessarily think about the dummy load. At least I never had before. I just said, okay, it's a dummy load and it's 50 ohms. 50 ohms is 50 ohms. Yeah, right. But it's not a resistor, no, it is an impedance. So, well, let's put that to the test. So let's start with the lower frequencies, and well, we kind of know that it works. This old Philco from the KLM is super good quality. I adjusted already this Daiwa. I did it in another video, compare it with the Marconi, and well, we can just put in power. I've got my 3 transmitters here. It is an FT891 that can produce 100 watts on HF. I have an older Yaesu, the FT2311R, which is the European version of the 23 centimeters, so 1250 megahertz. And I have an older, it's a QRP, it's a low power. It is the FT817, and it's a little brother of the 818, almost the same, just a little bit older. And it also has HF, but on low power, and it has 2 meters and 70 centimeters. So what I will do, we'll just use this here, the frequency, 40 megahertz, will go through this one. And this one was calibrated, and I will put it through this one on this dummy load, which should be able to go at least up to 30 megahertz. And then we can try later that same with my small dummy loads. Okay, that's connected. Let's see, I'm on USB. I probably need to change to FM. Not sure how much power I have. It is almost 100. Here it is exactly 100. So that is good. So let's try that again. I transmit. It's on the 150 setting here. It goes very close to the 10. We look here at this old one, but we also adjusted. It also says 100, and here you can also see the SWR, and it is not moving at all. Okay, let me take the same cable and connect it to the Marconi. Okay, yeah, sometimes the Marconi has a little bit problem to pick the right. Yeah, here we are. You see, almost 100, 40 megahertz. No problems here. Okay, all working as expected. 40 megahertz is within the range of this dummy load, and of course there is no problem. We could see the SWR was no return lost, so that was very good. The other needle didn't move at all. So now I want to go a little bit higher, so close to the 30 megahertz. Still in range, so that should also not be a problem. Okay, 28 megahertz. Let's see what that does. So putting the power. Here we go. Almost hitting the 10. Here also almost hitting the 10. And again the reflection, it does not go anywhere. So, but I saw we also have 50 megahertz here. What will it do on 50? I mean FM. And now we should see a difference, because it says it's rated for 30. And oof, that dummy load is good. It says here it is now a little bit less power, so it's like 9. It says here also 9. So this dummy load actually works a lot better than I thought. Okay, let's quickly test my homemade. It can do, of course, not the 100 watts, but if I do it very quickly, it's just to see how is the SWR, and maybe I need to close it. Oh, no returns also. When I do it very shortly, the resistors can take it. But also no return loss. Let's see what it will do on 28. Yeah, now it's warm. 28. No return loss either. We go to 50. Now it started moving. But very little. I'm actually surprised it still works. But you can see it is moving a little bit. So we could see already a little bit because my homemade was, it's hot, my homemade was constructed very poorly. You already saw a change that at 50 it was almost not moving, but it was moving. And on this much better constructed Velcro, the Sierra, it didn't move at all. No reflections, nothing. Then why did I not rate it for up to 50? And that is probably because it has a built-in power meter, and the built-in power meter says 90 watts, while this one says 95. And that is more about the RF pickup than that it is about that the impedance could have changed. So that is probably why. Let's go a little bit higher with this one and with this one. Let's put 2 meters in it. Okay, let's switch over from this one to the top one. I need to be careful because I think you can switch from the front antenna to the back antenna for 2 meters and 70 centimeters. So let's go bump down, 144, a little bit up, 144.1, and let me check that menu. Antenna rear, yeah, okay, I already did it last time apparently. The power is not that much, no. It's like 4 watts. Okay, so this meter can go up to 150, so the scale here should be the correct one. This one will show something, but it's probably not correct because of this meter is up to 30, but the impedance is maybe for higher frequencies. So let's try. Yeah, it's really only 4 watts. Here it doesn't even move, but if this is the scale, this is 10, I can go lower. And let me go even lower. Yeah, 5 watts it says here. And here it's a little bit lower. The Marconi also thinks it's almost 4. Here we go, 3.4. So what we saw here already is that if the meter is not rated for the correct frequency, it will say too much or too low. In this case, it said a little bit too much, this one. But the impedance stayed good. So if you use it as a dummy load only, it still works up to 140. Let's do 70 centimeters. The Marconi says, okay, it's about 3 watts. Okay, what do these 3 watts look like on a meter that is not rated for it? It says it's 15 watts even. And I got 10 watts return. Yeah, it goes completely banana. And this has nothing to do with SWR. This has to do because this meter is not rated for it. Interesting. So let's try the old one. This one is rated for it. Let's see what it will say. The SWR is good. And the power is 3 watts. So it's perfect. Okay, what will it do on the dummy load? That is not rated for it. This one here. Will it change the SWR? Or will it not? and only the meter is not correct. You see now we have a little bit of a return already. The power is still good, but we have a little bit of a return now, while it was completely dead before. So now the impedance started to change. Is my readout 50? Then it says 2.5. So the power readout is still kind of. Oh no! It thinks it is. No, it's wrong. 50. It thinks it's 25 watts. But the impedance changed. Look. It was actually quite interesting that this Velcro is actually much better. Except that the power meter is not correct anymore, but the impedance, at least up to 430 megahertz, is it's almost not moving, but it started moving, so that was interesting. And yes, these meters, of course, if you want to use them correct, you really need to have them for the right frequency range, and it showed, because it will just say too much value. So it thought it was 25 watts and it was only 3, but it is purely because it was not rated for that. And when we get the correct meter, it was spot on still. So what I like to try now is use the Kenwood, and they are quite honest about it. If the frequency becomes above 150, the needle should start moving. And the best you get on 30 megahertz only. So I like to do exactly the same, and then let's see what we see. Well, I just moved the cable from this one to this one, and I must say that I'm pleasantly surprised, because I still see 3 watts. Yes, there is a little bit of a return, but it is not that bad. It is 1.12, I think it says. So and because the power value is still the same, I think the impedance didn't change that much. So here they say 1.4, but I get a lower reading, even on 450 megahertz. Okay, then the homemade. Yeah, the homemade is a lot worse. The power is still good, and you can see here that it is already 1 to 1. So instead of doing 1.14, it does 1.2. And even if you touch it, it will of course change the impedance. So maybe if I close it, it will maybe even better. Okay, I closed it. Let's see if it improved. It's yes, look at that. So you see, the better you construct it, because the watts are still 3, that's correct, and the needle does move, but almost nothing. Now I put it back to the Kenwood, and on this frequency my homemade is better than the Kenwood. But of course it's for very low power, and the Kenwood is for higher power. So now I want to push it a little bit further. Only I cannot compare it too much, because 23 centimeters, it is 1295 megahertz. My transmitter is now on. I will put it to 1260 or something. And yeah, my Marconi cannot do it, so I cannot compare it. These dummy loads are absolutely not made for it, and I wonder what the homemade will do on that frequency. And yeah, we're just going to see. I like to see that the SWR becomes really bad, because you expect that to happen. Okay, 1290 megahertz, quite high. I have here the meter that is rated for that, and I connected it to the Marconi, The Marconi is not rated, it only goes up to 1 gigahertz, so I won't see anything. But at least I know that the input impedance is probably about right still for this 1290 megahertz. So when we go, we see, okay, there is some return. And the power reading is about 8 watts. Yeah, that's about right. Okay, well, let's now connect it to, I need PL. No, I can do first here the Philco. If it's not, the power reading will be terrible because of course it's not made for it. But what about the SWR? SWR is not even that bad compared to with the Marconi, so it's more or less the same as the Marconi. Only the power reading makes no sense because now it thinks it's 120 watts, and yeah, it is between 6 and 8 watts somewhere. Very, very positively surprised about, well, it is a good piece of quality, the Sierra. But it will go up. It's only that it's good to know that I have a dummy load that can reach those frequencies. Kenwood connected. Oof. The Kenwood is definitely not made for these frequencies. Look at the return. This is the Kenwood connected now. And we have a lot of return, and that is just because the impedance now doesn't make sense anymore. And the Philco here from the 60s actually did it a lot better. But Kenwood was very clear about it on the dummy load itself. So let's switch it over to the homemade. So here we have almost 6, and here it is almost to the crushing. Let's switch it over. I would be surprised if this one is better than the Kenwood. I cannot imagine, because we saw already construction does matter. Yeah, here it's even worse. Here it's higher and it's higher. So return is higher, and at some point it starts to measure also wrong. Oh, that what we saw on the power meter was interesting, because I did not necessarily expect that. If a power meter is not rated for a certain frequency, I would think, okay, the value is a little bit off, but we saw that it is times 100 off even sometimes. So this power meter from the Philco, well, the impedance stayed almost very, very good up to, well, I didn't measure between the 430 and the almost 1300 megahertz. There is a huge gap there, but on the 430 it was actually pretty good, and it was not that bad on the 1300 megahertz. So this Philco is really good constructed, but of course the power meter didn't make sense at all. And we saw that my homemade was really crap at high frequencies, and well, the Kenwood also. And even though they say here they only did 1.4 for 150 megahertz, but I could have put 1.2. It is actually a little bit better than they say it is. So, and then what about these super duper professional dummy loads? Well, it's attenuated dummy load, but yeah, if I just don't use the output, then it is still a dummy load. And here we have the other huge one. I think it's a WA500. And well, let's try to connect these and see. We should get a lot less return. First the Philco. Okay, remember that there. Now we switch over to the bird. Well, the bird does that a lot better. There is some return, but it could maybe also be my cable. Okay, then we have this other bird that was made for Harris. What will that one do? I just put it on top. with these low powers. I don't need the heatsink. What will this one do? It responds more or less the same. A little bit lower frequency, because the value is fractional higher here. Oh, I'm reading now the email that John sent me a few months back, and he said that this comes out of a big Harris transmitter, and these bird ones replaced the KDI ones, and the KDI ones were actually designed up to 800 megahertz, because I think it was a UHF transmitter, this Harris, and so 800 is more than enough. And these birds were a little bit better, or they were better, and they could go up to 1.2 gigahertz, and we are very close. Well, we are almost at 1.3 even. So yes, it will go a little bit less good, and this one was better on the simple fact that when I look here in the specifications, up to 1 gigahertz, it should do 1 to 1.10, and around up to 2 gigahertz, it can go to 1 to 125. Okay, I like to see this RF tab that is on it, because it is an attenuator, and this one they do about, I think this one is 30 dB, so it should be fine because I have less than 10 watts, and I can even do plus 30 dB with this one. So yeah, I'm not afraid. The spectrum analyzer can do that frequency, and then we can see how many dBs, and then we should be good. Let me just connect this. So 30 dB in between, auto tune it. Here we go, and it says it is about 7 dBms, 7.5, and then with this one is 37, around 37 dB. Well, that is still 37. That is still below 10, because that would be 40 dB. Yeah. So now we have 40 dB, so now we should have minus 3, 4 or something. So let's see what we have. Yeah, minus 3.9. Maybe if I have another scale, we can see a little bit better. Yeah, still 3.92, so almost 4, minus 4 dB. So that means we're still around this 36, 37 dBms. So our SWR meter said it was around 7 or 8 watts, and we found out that we had around 36. That is 4 watts, and 37 somewhere there, so it was between 4 or 5 watts. But then we get a rough idea, because I don't think this is a really good way of measuring your power because we have so many dBs in between. Maybe it was like this 38 instead of, because it is logarithmic, so it's a huge difference if it is 6, 7 or 8, because we lost another dB in the cable somewhere. And then it could be correct what the meter said. It was about 7, 8 watts. So in these high frequencies, it would not be weird if we miss 1 or 2 dB in a cable somewhere. So that was my lazy Sunday. the dummy load looks a lot better again, and it performed even better than I thought. And the Daiwas also, I was able, they are almost in new state, and for some I needed to replace the feet, and for some it was not possible, so then I had the stick-ons, and but it is also like new, and they seem to perform still very good. And thanks again, John W7ZQ Quebec, for sending me these high frequency dummy loads. Amazing, and it was a great test to see how all my other dummy loads also performs. Thank you for watching, and I hope to see you next time.